Hello, today we are going to learn about the distribution of PAH and fate to marine and human exposure. One type of chemical that affects our waterways is polycyclic aromatic hydrocarbons. It's a big word to say, but there are chemicals that occur naturally in coal, crude oil, and gasoline. And it's also produced when crude oil and gas food and garbage are burned together. Mostly in a rural area, many people will burn their garbage. Based on the EPA websites, is that burning of garbage actually releases a lot of this PAH into the environment. So it's not really a good idea to burn things like plastics because it releases a lot of those hydrocarbons into the environment. Another common source of polycyclic aromatic hydrocarbon will be things like the oil spills. So if you remember or hear about that big oil spill back in 1989, the Exxon Valdez oil spill, and then also that 2010 Deepwater Horizon oil well blowout that left 168 million gallons of oil into the water. 31 years ago, on 24th March 1989, communities in Prince William Sound, Alaska awoke to horrific news. The Exxon Valdez and oil tanker had leaked 11 million gallons of oil into the sea. Fishermen desperately began collecting oil in 5-gallon buckets. Exxon, meanwhile, responded by burning floating oil and dumping toxic oil-based chemical called dispersants. Dispersants break oil apart into smaller droplets, and this was assumed to enhance natural dispersion and degradation of oil, thereby cleaning up a spill. Instead, the dispersants form chemically enhanced oil particles that prove to be more toxic to human and the environment. And here you can see a couple of pictures that demonstrate the effects of oil spill on the environment. You can see how both plants and animals affected. And this one is actually some embryos of salmon. There was a study shows that their hearts were actually deformed and they had a lot of fluid built up around their hearts and causing them not to live longer and affecting their ability to swim as fast.
One of the biggest U.S. oil spills happened 30 years ago this week. It's been 30 years since the waters of Bligh Reef in Alaska were contaminated with more than 11 million gallons of crude oil after an Exxon oil tanker impacted the reef's seabed. Today, we revisit how the Exxon Valdez oil spill happened. According to The Atlantic, on March 24, 1989, the Exxon Valdez oil tanker was entering Alaska's Prince William Sound. It had departed from the Trans-Alaska Pipeline Terminal on March 23 at 9:12 p.m. and was carrying 53.1 million gallons of oil. At 12:04 a.m., the tanker slammed into Bligh Reef, tearing open its hull and spilling 11 million gallons of oil into the water and the surrounding environment. That's the equivalent of 17 Olympic-sized swimming pools. According to Scientific American, nearly 2,000 kilometers of the shoreline were contaminated. Wildlife in the area was also severely damaged. Thousands of otters, harbor seals, seabirds, and fish were killed. According to the Environmental Protection Agency, 3 methods were used to clean up the spill: burning the oil on the water surface, mechanical cleanup via oil skimmers, and chemical dispersants. High-pressure hot water was also used to clean the surrounding beaches until it was determined that it was cooking microorganisms present in the shores, which in turn damaged the soil. According to a case study by the International Tanker Owners Pollution Federation Limited, ExxonMobil had to pay $4.3 billion as a consequence of the spill, in addition to the $2 billion it spent the first year on cleanup efforts. The Exxon Valdez oil spill is the second largest spill in history, second to the Deepwater Horizon oil spill in the Gulf of Mexico, where an explosion at a BP oil rig killed 11 workers and spilled 53,000 barrels of oil per day for 3 months.
These are the transport and fate of PAH in the environment. Firstly is atmospheric emission and deposition of PAH. The atmosphere is the most important means of PAH dispersal. It receives the bulk of the PAH environmental load, resulting in PAH being abundant in the environment. PAH are emitted to the atmosphere primarily from the incomplete combustion of organic matter. The combustion sources can be either natural or anthropogenic. The natural sources include volcanoes or forest fires, while the anthropogenic sources are vehicle exhaust, agricultural fires, power plants, steel plants, foundries, and other industrial sources. PAH tend to be found in greater concentrations in urban environments than in rural environments because most PAH sources are located near urban centers. Once released to the atmosphere, PAHs are found in 2 separate phases, a vapor phase and a solid phase. The variability in vapor pressures of different PAH compounds cause the individual PAH to distribute in different concentration in the vapor. Second is PAH in the surface soils. Atmospheric PAH are continuously deposited to the earth by dry or wet deposition process. Some of these PAH are from nearby sources. such as automotive exhaust from adjacent roadways. Other PAH are from more distant sources and have been carried various distance through the air. In the meantime, PAH can be added to soil if fill material contain PAH. When PAH are deposited onto the Earth's surface, they can become mobile. The third is PAH in sediments. Once PAH are incorporated into sediments, they are somewhat immobile because their non-polar structure inhibits them from dissolving in water. Nevertheless, PAH are not completely insoluble. Thus, small amount of PAH do dissolve and become included in the pore water where they are bioavailable. The presence of pore water organic colloids can increase the concentration of PAH beyond their aqueous solubility because PAH will be sorbed onto this organic colloid. Marinas are an important source of hydrocarbon enrichment in nearshore areas. As you can see in the figure shown, the motors of both expel combustion product and unburned aromatic and non-aromatic hydrocarbon from gasoline, diesel fuel, and lubricating oil into the water or into the air just above the water surface. Gasoline engines are a proportionately greater source of PAH than diesel engine. The figure showed the movement through water of both disrupt the surface microlayer of water, generate surface wakes that disturb shoreline sediments, and produce subsurface water turbulence that can cause resuspensions of PAH from bottom sediment. The surface microlayer of water often contains concentration of hydrophobic contaminants that are higher than those of the underlying water column. PAH concentrate in this microlayer. For example, concentration of PAH were found to be 18 times higher in the microlayer than in the water column in coastal waters of South Carolina. Main processes determining the fate of oil and PAH in the marine environment. Atmospheric PAH deposition on surface waters, corresponding to most cases of chronic pollution, and pathogenic PAH, entering by oil spills, corresponding to acute pollution, undergo similar global abiotic and biotic processes. PAH from natural oils travel through the water column to the surface and finally follow the same processes as the previously described PAH. The movement of PAH into the water column by dissolution or particulate suspension exposes the molecules to degradation and transport by organisms. Microbes such as bacteria, yeast, filamentous fungi in the water have limited capability to metabolize PAH. High molecular PAH are more resistant than low molecular to microbial degradation. Unmetabolized molecules eventually accumulate in the bottom sediments where the microbial degradation process continues. If the sedimentation rate is high and the sediments are not physically disturbed, PAH can persist for many decades. Polycyclic aromatic hydrocarbons are ingested by a variety of invertebrate and vertebrate organisms. In addition to microbes, mammals, birds, fish, and many invertebrates metabolize and excrete some of the aromatic and non-aromatic hydrocarbons ingested during feeding, grooming, and respiration. Although bivalve mollusks and some zooplankton are either unable or marginally able to metabolize hydrocarbons, they can transport and temporarily store them. Accumulation of PAH by organisms is associated with poor metabolic capabilities, high lipid content, and activity patterns or distributions that coincide with high concentration. Aquatic algae can assimilate and metabolize some PAH.
How are we exposed to PAHs? We can be exposed to something in three major ways: by ingesting it, by contact with the skin, or by breathing it in. All of these exposure sources can be relevant. One of our most significant exposure pathways for PAHs is our diet and eating foods cooked in certain ways, most notably grilling food that particularly meats with high fat content. Other ways, consuming marine foods that contaminated with the PAH itself. Breathing in PAH can be an issue for both the public as well as for workers in some specialization. PAH are found in the air we breathe, usually at a low level. Urban air generally has higher levels of PAH compared to rural areas, particularly urban areas near construction sites, rail lines, highways, and ports, since PAH are produced by vehicles that rely on fossil fuels.
We might expose to PAH through breathing air containing PAH in the workplace, breathing air containing PAH from cigarette smoke, wood smoke, vehicles, and asphalt roads, in contact with air, water, soil near hazardous waste sites, eating contaminated food, drink contaminated water or cow's milk, and nursing infants of contaminated mothers. So we have reached to the end. As for conclusion, PAH are released to the environment through natural and synthetic sources with emissions largely to the atmosphere. Synthetic sources provide a much greater release volume than natural source. PAH are transported from surface waters by volatilization. In soil and sediments, microbial metabolism is the major process for degradation of PAH. PAH have a potential effect of the environment both directly and indirectly. Thank you. Bye.